When the computer finally decoded the signal, the room went silent. Scientists stared at their screens, checking the data again and again, because what they were seeing was impossible. On Pluto, 3 billion miles from Earth, something was moving. Not drifting, not shifting with the wind, moving with purpose. And when they zoomed in on the thermal readings, the numbers made absolutely no sense. This tiny, frozen world, abandoned at the edge of space, was hiding something that would rewrite everything we thought we knew about life in the universe. But I'm getting ahead of myself. The full story, the one that explains what they actually found and why it terrified them, that's coming at the very end of this video. Trust me, you need to hear the whole story first. Quick question before we dive in. Are you watching this on your phone or computer? Drop a comment right now. I'm curious where you all are exploring from today. All right, let's rewind, because to understand what NASA discovered, we need to go back to the beginning, back to when nobody even cared about Pluto anymore. The year is 2015. New Horizons has been flying through the darkness for 9.5 years. Most people have forgotten it even exists. Back in 2006, right after launch, the world turned on Pluto. Scientists demoted it, headlines mocked it. Sorry, Pluto, you're out of the club. It became a punchline. But on July 14th, after nearly a decade in the void, New Horizons woke up. It had one shot, just a few hours to capture everything as it screamed past Pluto at 30,000 miles per hour. If anything went wrong, a single camera glitch, a bad angle, that was it. There would be no second chance. The first image took hours to download. Remember, we're talking about sending data across 3 billion miles of empty space. It crawls back to Earth 1 pixel at a time. Mission Control watched their screens, waiting. And when that first high-resolution photo finally assembled itself, someone in the back of the room whispered, "Oh my God." What they saw. It wasn't gray. It wasn't dead. The surface was painted in reds, whites, and golds. There were mountains casting long shadows. There were textures and layers. And right there in the center was a massive, bright heart staring back at humanity. But here's the thing. Pretty pictures are one thing. What came next was something else entirely. The data started rolling in. Temperature readings, atmospheric composition, geological surveys, and with every new batch of information, the scientists got quieter, because none of it made sense. Pluto is smaller than our moon. It's so far from the sun that sunlight barely reaches it. By every law of physics, it should have frozen solid billions of years ago. It should be a dead rock covered in craters just floating through space like a cosmic graveyard marker. Instead, New Horizons found a world that was active. The surface of that heart, scientists call it Sputnik Planitia, was smooth, not a single crater. That meant the surface was young, really young. Something was erasing impacts, something was resurfacing the planet. Then they spotted the mountains, 2 massive peaks on the edge of the heart. One of them, Right Mons, was 90 miles wide and over 2 miles high. But it had a hole in the center, a caldera. And the sides weren't smooth. They were lumpy, covered in mounds of material piled on top of each other, like someone had been squeezing cosmic toothpaste onto the surface. The analysis came back cryovolcano, an ice volcano, but not like anything on Earth. This thing erupted slush, a mixture of water ice, ammonia, and methane. It vomited antifreeze onto the surface. The question nobody could answer. One scientist asked the question everyone was thinking. Where is the heat coming from? Pluto should be cold, dead cold, nuclear winter cold. But something inside was warm enough to melt ice, warm enough to power volcanoes, warm enough to keep the surface moving and breathing like a living thing. They started digging through the data, looking for answers, and that's when they found the cracks. Giant fractures ran across the surface of Pluto like scars, massive canyons stretching for hundreds of miles, the kind of cracks you get when something freezes and expands, like a water pipe bursting in winter. One of the lead scientists pulled up the images and overlaid them with gravitational data. She stopped, looked at her colleague. "This only happens if there's water underneath." The room got very quiet. See, when water freezes, it expands. If Pluto had a subsurface ocean that was slowly freezing over millions of years, the ice would push outward, cracking the crust from the inside. The fractures matched the pattern perfectly. But there was a problem. If there was an ocean under the ice, it should have frozen completely by now. Pluto is too small, too cold, too far from any heat source. So why was it still liquid? The heart's secret. Then someone noticed something strange about that giant heart. Sputnik Planitia wasn't just a pretty shape. It was a massive basin filled with nitrogen ice. Heavy ice. Really heavy. Now here's where the physics gets wild. That weight should have thrown Pluto off balance. Imagine tying a bowling ball to a basketball and spinning it. The heavy side would drag it around, right? The planet should have tipped over, rotating until the heart faced away from its moon, Charon. But it didn't tip, not completely. It stuck in this weird, unstable position, frozen mid-rotation. They ran the math again and again. The only way the numbers worked was if there was something underneath the heart acting as a counterweight, something liquid, something sloshing around under the ice, redistributing mass and keeping the planet balanced. A subsurface ocean directly beneath the heart. The ammonia mystery. But liquid water at those temperatures, impossible, unless ammonia. Ammonia lowers the freezing point of water dramatically. It's nature's antifreeze. If Pluto's ocean was loaded with ammonia, and the spectral data suggested it was, then the water could stay liquid even in the brutal cold, even 100 miles under a frozen crust. And that ocean wouldn't just be sitting there. It would be in contact with the rocky core at the bottom, the radioactive core that's been slowly decaying for 4 billion years, pumping out heat. Heat that would create convection currents in the water. Heat that would transfer to the ice above. Heat that would power those volcanoes. Pluto wasn't dead. It was alive. It had a beating heart powered by a hidden ocean. The bigger question, one of the younger scientists, a microbiologist brought in to consult, raised her hand. If there's liquid water, and there's heat, and there's chemistry happening, what else is down there? Everyone turned to look at her. She pulled up a slide. In Earth, everywhere we find liquid water, plus energy, plus organic chemistry, we find life. Every single time. Deep ocean vents, Antarctic ice lakes, inside rocks miles underground. Life finds a way. The lead scientist leaned back in his chair. "Are you suggesting?" She said, "I'm saying we need to look at the atmospheric data again, because if something is producing gases down there, we might be able to detect it from the surface." What they actually found. So here's what NASA found that shocked scientists, and I mean genuinely shocked them, kept them up at night, made them question everything. When they analyzed Pluto's thin atmosphere, they found something unexpected. Seasonal changes. The atmosphere was growing and shrinking, but not just because of temperature. The composition was changing too. Trace amounts of complex organic molecules, tholins, hydrocarbons, the building blocks of life. They were forming high in the atmosphere from sunlight hitting methane. That was expected. But here's what wasn't expected. Isotopic ratios in the nitrogen were off. Slightly off. The kind of off you get when biological processes are involved, when something is consuming and releasing nitrogen in a cycle. Now, before you freak out, this isn't proof of life, not even close. It's a hint, a whisper, an anomaly that could have a dozen different explanations, but it's the kind of anomaly that makes scientists pause. Because if, and this is a massive if there are microbes in that subsurface ocean feeding on chemical energy from the core, processing nitrogen and ammonia, releasing gases that eventually bubble up through cracks in the ice and into the atmosphere, the numbers would look exactly like this. The reality check. So here's the hard truth. We can't know for sure, not from 3 billion miles away, not from a flyby mission that lasted a few hours. To really answer this question, we'd need to go back. We'd need to land, drill through 100 miles of ice, lower a probe into the dark ocean and see what's swimming around down there. And we're not doing that anytime soon. New Horizons is gone, sailing deeper into the Kuiper Belt. The data is all we have, and that data is both incredible and frustrating because it tells us just enough to know we're missing something big. But why this matters? Here's why this discovery, this hint of possibility, is actually kind of terrifying. We wrote Pluto off. We demoted it. We called it a cosmic nobody, too small, too far, too dead to matter. And we were wrong. If Pluto, of all places, can have an ocean and chemistry and maybe life, then what else is out there? What about the hundreds of other dwarf planets in the Kuiper Belt that we haven't even visited yet? What about the frozen moons orbiting Saturn and Jupiter? What about the rogue planets drifting between the stars? We thought the habitable zone, the safe space where life could exist, was this narrow ring around the sun where water could stay liquid on the surface. Pluto just told us that's ridiculous. Life doesn't need sunlight. Life doesn't need surface water. Life just needs liquid, energy, and time. And the universe has plenty of all three. So let me ask you this. After hearing all of this, the ocean, the heat, the chemistry, the anomalies, do you think we should go back? Should we send another mission to Pluto? Should we drill through that ice and find out what's really down there? Drop your answer in the comments. I genuinely want to know what you think, because this isn't just about Pluto anymore. It's about how we search for life in the universe. If you loved this deep dive into the edge of the solar system, smash that subscribe button. We're exploring more shocking discoveries every week, and trust me, you don't want to miss what's coming next. Thanks for watching. Keep looking up, and remember, the universe is way stranger than we ever imagined.